Hello! So, if you remember, in the first part of the question, we were asked to show that t cubed divided by t plus 2 was this thing here. But now we're giving something seemingly completely different, and yet it's part of the same question. So that must mean, so we've been asked to find this integral here. If you notice, this integral has got nothing to do with this, apparently. But because it's part of the same question, we must have to use it at some point. So basically, let's just go ahead and try and work this out, and then we'll eventually call on this, I reckon, at some point. So we're asking ourselves, what is the integration between 1 and 2 of 6t squared multiplied by the natural logarithm of t plus 2 with respect to t? Okay, well, look at that. I don't know how to integrate a natural logarithm, all right? And if you also look at that, I've got a function involving t, I've got 6t squared, and another function involving t, a natural logarithm of t plus 2. So I've got two functions involving t being multiplied together. That must mean, well, if it was differentiating, I'd use the product rule. Two functions being multiplied together and I don't want to differentiate them, I use the product rule. So here I use the integration version of the product rule, which is called integration by parts. Now, integration by parts runs that the integration of one function that I call u multiplied by the derivative function, basically. So v is just called the derivative of v, okay? And that should be equal to my two original functions, so uv minus the integral of this thing the other way around. So here I called one of my functions u and the other one the derivative of v, okay? So here now I'm going to call it v multiplied by the derivative of u. So my other one's the derivative of u. So basically I need to go up here and I need to decide what's u and what's v. Okay, I need to decide what's u and what's dv. At the moment I'm kind of here in the formula. I'm here on the left hand side in the formula. So I need to decide, well, what is u and what is dv? Well, bear in mind that I need four things. I need u, and then I need du. Okay, so I need to basically call whatever I call u, I need to be able to differentiate it. Okay, and then likewise, whatever I call dv, okay, I'm going to end up back at v. Okay, so I need to be able to, whatever I call dv, the derivative of v, I need to integrate it in order to get back to v. Well, if you look up here, if I called this dv, I'm not able to integrate that. I don't know how to integrate a natural logarithm. So there's no point calling this the derivative of v, because I've got no idea how to integrate it. So therefore, this 6t squared has to be called dv, the derivative of v, okay? Because then that means that v, I just integrate it, so I raise the power by 1, so it becomes t cubed, and I divide by that new power, so it's going to become 6 over 3, which is just 2. So it's going to become 2t cubed, okay? And then that just means then that u must be my other function, so my ln of t plus 2. Well, what then is the derivative of the natural logarithm of t plus 2? That's what du is. Well, you're happy it's just going to become 1 over t plus 2 multiplied by the derivative of t plus 2, which is just 1. So that's fine, okay? And now, basically, this is the ingredient list which I need to fill in my integration by parts. But be careful, because if you notice, this integration has got some limits going on, okay? So this integration has got some limits going on. So where do the limits go down here? So this is, say, for example, between a and b. I'm just going to do it generally, okay? Well, fairly obviously, these limits are going to carry across to this integration on the right-hand side as well, but they're also going to carry across to this integration here. So basically, to uv here. So I also then have to stick a and b, or my limits, into uv as well. Okay, but that's fine. Okay, so I've got the integration of my original thing is equal to uv between my limits of 2 and 1. So my uv, well, here's my u, it's natural logarithm of t plus 2, multiplied by my v, which is 2t cubed. Okay, and those are between my limits of 1 and 2. Okay, fine. And then I've got that minus the integration between 1 and 2 of v. Well, v is just 2t cubed. V is just 2t cubed, times by du, which is just 1 over t plus 2. Alarm bells should be ringing. Okay, so let's first of all just tidy this up just a tiny little bit. I'm going to write that as my first bracket here. I'm going to write that with the 2 out the front, so 2t cubed natural logarithm of t plus 2, and I could stick the limits in if I wanted to, but you know what, pfft, can't be asked. So 1 and 2 minus, okay, now look here, I'm going to pull my 2 out, and there's a reason for doing that, because if you haven't seen it, you're going to see why in a minute. If you have seen it, then you'll understand why. Okay, that's then left with t cubed multiplied by 1 over t plus 2 with respect to t. Now notice whenever I multiply two fractions together, if I've just got a number multiplied by a fraction, that number effectively just jumps up on the top, because I can treat that as t cubed over 1, multiply the numerators and multiply the denominators together. So that then effectively just becomes t cubed, between my limits, t cubed over t plus 2. Wait a minute. Remember how I said at the start of the question that this, which seemingly had nothing to do with this, will be used at some point? Well, look, I've shown that t cubed over t plus 2 is t squared minus 2t plus 4 minus 8 over t plus 2. So when I'm trying to integrate effectively t cubed over t plus 2, that's just what I found in the last question, I can just replace all of that. I can just replace all of that with t squared minus all of my thing up there. So all I've done there is just replace t cubed over t plus 2 with the thing that I found in the last question, because I think you'll agree that looks a lot better to integrate than my t cubed over t plus 2. Okay, let's not worry about this first bit at the moment. Let's just focus on this integral here. So basically, let's go off and try and find what this integral is down here. Okay, so let's do my limits. So I'm going to have brackets, and they're all going to be between 1 and 2, and then I just integrate everything inside that integral. So it's a definite integral. Let's first of all look at the t squared. I integrate it, raise the power by 1, divide by that new power. So it's going to become 1 over 3 t cubed, okay, divide by that new power. Then I've got minus 2t, so minus, raise the power by 1, it's going to become t squared, divide by that new power. The 2 over the 2 will just cancel, so I'll just be left with t squared. Okay, cool. I've got plus 4 then, so that should become plus 4t, okay. Then I've got, look at that, minus 8 over t plus 2. Well, you should be pretty good at recognizing these things by now, because look, I've got a function on the denominator, and I've got something to do with that function on the numerator, even if you can't see it yet. If I write that as minus 8 times 1 over t plus 2, okay, then I'm going to call that minus 8 times, well, what is the derivative of t plus 2? What is the derivative of t plus 2? That's just going to be 1. So effectively what I've got there is a function on the denominator, and the derivative of my function on the numerator, okay, and, or this is technically in terms of t, I guess, but basically because I've got this thing going on, then I just know that that's just equal to the natural logarithm of whatever my function on the denominator was, whatever, in this case, t plus 2. So that's equal to ln of t plus 2. Okay, because I've just been able to spot that I've got a function on the denominator and I've got the derivative of the function on the top, I know immediately that's the natural logarithm of whatever my function was on the denominator. Okay, you need to get really good at spotting this. It's like a really useful identity when you're integrating stuff. If you've got a function on the denominator and the derivative of the function on the numerator, it's just the natural logarithm of whatever that function was on the denominator. Okay, now basically I can replace all of that back in there. Okay, so let me just write this out. So there you go, I've just simply replaced all of that in there. Okay, don't forget that you've still got the 2 out the front. It's very easy after doing all of that integration to forget the 2 and then you get the wrong answer. That's not what you want to happen. Okay, and then all you just have to do is just stick 2 and 1 in, stick your limits in and see what happens. So, okay, let's just go for it. I'm going to do it fairly quickly because there's quite a lot to go through there. But basically, let's just stick 2 in for t first of all. So I've got 2t cubed, so 2 times 2 cubed, minus the natural logarithm of 2 plus 2, that's going to become 4, okay, and then I do the same with sticking 1 in, so that's going to become minus, that's going to become 2 times 1 cubed, minus the natural logarithm of 1 plus 2, that's going to become natural logarithm 3, okay, then I've got minus, so let's look at this thing over here now. Oops, sorry about that. I've then got to stick 2 times, so let's do a third. Stick 2 in first of all, third times 2 cubed, minus 2 squared, plus 4 times 2, minus 8, natural logarithm of 2 plus 2 is 4, yep, okay, then minus, don't forget I've still got to do times by 2, so minus, I'll do it down here, minus 2 times, Actually, I've got to be very, very careful here. I'm just going to leave that in a square bracket and just treat the limits separately. So I'm not going to multiply 3 by 2 yet. Okay, third times 1 cubed minus 1 squared plus 4 times 1 is just 4 minus 8 natural logarithm of 3. Okay, and that's all times that. Okay, the reason why I was very careful about multiplying by 2 is because you're not just multiplying by 2, you're multiplying by negative 2. So yeah, when you multiply 3 by 2 here, it will become 2 there, but be careful because it comes multiplied by 3 by negative as well, so it becomes a negative times a negative, which is just a positive. Okay, fine. Let's just get through this quickly, and it's just basically number crunching now. So 2 times, that's going to become 2 to the 4, so it's 16. Okay, so 2 times 2 cubed, that's 16, minus the natural logarithm of 4. Okay, that's that thing sorted. Minus 2 times 1 cubed, that's minus 2. Then I've still got minus times that, so it's going to become a positive, ln 3. Okay, fine, whatever. Minus 2 times, well, 8 is 2 cubed, so it's 8 over 3. So it's going to become 16 over 3 when I multiply by 2, so 16 over 3. Then be careful because I'm taking the minus with me, so I'm going to become positive 2 times 2 squared, so that's going to become plus 8. Okay, then again negative comes with me, so it becomes negative 4 times 2 times 2, that's going to become positive 16. Okay, and be careful again, negative comes with me with the 2, so that becomes positive 16 ln 4. Okay, I hope I'm going to end up with the right answer and don't end up with anything wrong here. So then I've got a third times 1 cubed, so that just comes times by 2, so that's going to become 2/3. Okay, minus 1 plus 4 minus, sugar, I forgot to do the 2. Okay, that's fine. That's just 2 multiplied by 1 squared. I'm getting 2 ahead of myself. Multiply this by 2 as well. That's going to become 8. Okay, multiply this by 2, so that's going to become minus 16 ln 3. Okay, let's try and combine together what we know. Do you know what? I'm just going to do that. I'm going to leave it to yourself. You know, you can do this totally yourself. What can I see is going to combine together? Well, I've got a ln 4 there, and I've got 16 ln 4 there. Okay, they're probably going to combine together using laws of logs, and the same thing with that and that. So basically, I'm going to come to an answer, and I'm going to show you what I get, and then let's see if you get there as well. Okay, so I've kind of combined all the numbers together and I've got to there. Hopefully that's right. What's 16 minus 14 over 3? I haven't combined all the numbers actually. 16 over 14 over 3. I've got to multiply by 3, so that's going to become 108 minus 14. That's going to become 104. That's going to become 94 over 3. Of course you've got a calculator. I don't know why I'm just not using a calculator. But look, I've got laws of logs going on there because I've got the same base going on. So that's just going to become 15 ln 4 minus 15 ln 3. I'm going to pull a 15 out, okay? Then when I subtract 2 logs together, then that just becomes dividing inside the kind of base, I guess, or the number. So it's going to become natural logarithm of 4 over 3, okay? And then you can just check and see what that comes out as. But actually, I've just looked in the question anyway, and they wanted us to leave it in ln 3 and ln 4 anyway. So it's a number plus something ln 3 plus something ln 4. So actually, we didn't need to do that last step at all. We just could have just left it as, well, I guess that. We could just combine that together. So that's 15 ln 4 minus 15 ln 3. Okay, so we could have just left it like that. Are they going to be fussy about the negative? We could always get rid of that negative, I guess. Yeah, go on then. Go on then, let's get rid of that negative. Let's get rid of that negative there and turn it into a positive just by bringing that power up there. Okay, so that becomes -1, and then it just becomes negative, that just becomes 3. Oh no, they wanted to leave it like, oh, okay. Just leave it like that. Yeah, so I'm trying to do too much in the calculator, but hopefully that just tries to make sense to you.